It was good, yo. Welcome back to Guy Rants and Loses the point of the topic. But today I actually have a speech that I have to do about AI, so I thought might as well just do a little practice run. Haven't made my outline yet, so it's just gonna be unstructured. But the main thing that has really bothered me, at least when I'm seeing all this stuff about AI, I think the environmental concerns are pretty legitimate, even if some of them are for the wrong reasons. Just in general, the environmental concerns are real. The economic concerns for sure. You're seeing a lot of people. Well, at least this was true a little bit ago, where people were seeing a lot of companies kind of do the Big Short. I don't know if anyone has seen that, but let's just say that we're automating a lot of our processes and then not align any success metrics to them. So then people see AI on the label and oh wow, this is really cool. And then they, don't actually improve productivity with them. And then now you're seeing software engineers are getting hired again because the systems engineers, the super specialized cybersecurity analysts, those people were too expensive. So why don't you just have the normal software engineers come back and fix all the problems that you made with using AI? Or you saw Gemini just get forced into everything Google related, and they're using their fast model, which last year was not particularly good. I don't think it could even make a website. It couldn't do some basic data structures and algorithms work. So I think the number was 1,000,000 lies a minute. And that's with the very common guardrail to ground your reasoning with the sources that are provided. I remember I was doing research for a workshop that I had, and I was just looking for information about 1,000 cranes. I don't know if anyone's ever heard of it, but you fold 1,000 paper cranes, you get a wish. Cranes said to live 1,000 years. They had different colors. This stuff is pretty grounded, and it gave me some information talking about where it came from. And then the source that it was just a museum piece. And where they said that the founding of it was just the location of the museum piece, which was completely unrelated to the mythology, the mythos, because it could have been from Buddhism, it could have been from China, it could have been from Japan. It got popularized in Japan, and it's just there's no one grounded reason to just say that it was from immigration, and there's not one particular city which it was from. I forgot what the tradition is called, but bottom line is, it wasn't great. But by forcing Gemini onto everything, it improved their shareholder value, and it got a little bit more investment, and it also helped their AI super team. I forget what they're called, but they have a deep lab. Nah, I don't remember. But bottom line is, it was strange to say the least. It's been a very strange time for watching developments in artificial intelligence, but all of that aside, I think it's been met with a lot of animosity, which is fair, because it's revolutionized people's lives unconsensually. It wasn't a very significant technology for a while. I think we were still working without a lot of the... Unless you were in software, you didn't really notice developments in AI. It lost a lot of funding leading up, I think right before the 2010s. It was winter. I don't know. It was called the winter purge. But right after Eliza was made, which was a therapist, it was a super fundamental natural language processing. It's something called Ruby, and Ruby does this thing called regex matching very well. And let's say you had the word and you had the word band or land, it would match up that and then provide you with information. Or you could make it so it only scans the start of a word. You could make it so it just matches the first substring, which would be the last and in land, or I can't think of a word at the top of my head. Well, operand, for example, would find that and at the very end, and you could replace it with something. So then it would just spit back whatever you said to it with some memory features. If you said her and you're referencing your mom, it would replace the her. When you were continuing the conversation, you said her again, it would fill it with your mom. And then the next time you reference her and you have a different name, it would update that, for example. So this is something which we call language processing, and it's a super fundamental operation, but the way that we do it now are very different. But I'm not here to drill about all the technical details. I think it's more interesting to just talk about artificial intelligence as like a concept. Like, why was it made? And very famous person in computer science, Alan Turing, just had this idea that, oh, we should develop things that can simulate human cognition. Like, we want to solve our problems in new ways. And it's probably because he came from a time where you were mapping super basic logical operations. If any computer science people out there, I think the class from me was 154, formal languages and automata. And automata are machines that do very basic operations. They store information, and then you are directly programming logic onto those machines. Like, super basic example. How do I say this? Like, super basic example, there's a finite state machine, and at each state, let's say you have a particular node, you say, okay, I'm going to go to the next thing if I read this particular symbol. And this is a DFA, discrete finite automata, where for every particular thing, let's say you only had a language, that's like the alphabet, for example, and you had A and B. If I see an A, I go to this node. If I see a B, I go to this node. And then you just program things based off of that. And you can, hopefully, that speaks for itself, how you can see that development. And this is randomly going to go into Left 4 Dead. This is my first time playing Left 4 Dead 2. I ran out of Overwatch footage. I'm probably going to make some more, but because this is slowly just turning into an Overwatch channel because I've not been gaming much. And I deleted Fortnite off my computer. But, yeah. And you had to program all of your logic directly on the computer. And if a little history on computer science, you started with zeros and ones. I feel like a lot of people have heard of binary as an idea. It's like true or false. And you went from there to, okay, I now have this language called assembly. So you have, in between, you had logic, which is, let's say this, if I do this, then that. I have and, I have or, and or in computer science is not the or that we know for humans. Usually when you say or, you mean the mutually exclusive or. I'm like, you can have this or you can have that, but you can't have both. Or just means one of those things can be true. So 2 plus 2 is equal to 4, or 2 plus 2 is equal to 5 is true, because 2 plus 2 is equal to 4. Only one of those things needs to be true in order for that or statement to be evaluated as true. And going from there, you were able to program all other gates, is what they call them, or and nor are gates, and or and not, I think, was the three fundamental ones. Or and nor. None of them are true. One of them is true, and then and is both. Yeah, I think those are your fundamental gates. You can program all the other ones, but those are your basic logic operations. So now I can say, if this thing is true, if both of these things are true, if none of these things are true, then you do something, or you program into other things. And there's a whole class on it. For me, it was called computer architecture, where you learn all about how you use those operations to actually turn into code. But now you have this code called assembly, and that's where super granular control. You tell your computer, okay, go to this memory address. If you've ever seen a motherboard, you'll notice that your RAM, your random access memory, is super close to your CPU. And you do operations in your CPU with a certain amount of cores, a certain amount of registers. You'll learn about this in your operating systems class. It's slowly just turning a lecture, like general lecture for computer scientists, about how those operate and schedule operations. But how your computer does it is relative to just the registers for assembly. And then you can understand the memory hierarchy from there. And you just, whenever you want to do something with your CPU, which is your central processing unit, you load stuff into those registers. And then if you need more information outside of those registers, that's stored in your RAM, and then your SSD, and then your HDD if you have both. And it gets slower the further you get away from your CPU, because it just has to travel a physically further distance. And the other thing that you will find out is that memory is stored hierarchically, which is relative to the physical distance that you have to traverse, but it's also basically traverse linearly. So you're like, okay, I need to jump to these different areas, and that takes more time. And I'm going to stop talking there because I'm feeling my memory actively shorting on the classes that I just learned. But taking this all back to AI, when you have that coding language assembly, you have to write code that represents solving the problem that you have, and you have to turn the problem into one that can be understood on your computer, and that's a difficult task. Right? Writing code and solving different problems with that code is such a significant issue for people. Like the super basic one, Fibonacci sequence, right? Solve the next thing in the Fibonacci sequence. For assembly, you had to create a loop, and that loop had to have an adder that remembered the previous two things that you built, but you had to directly tell the computer where to store those two things and then keep adding them. And if you're unfamiliar with the Fibonacci sequence, you're adding previous numbers starting with 0 and 1 to create the next number. So you do 0, 1, 0 plus 1 is 1, and then you 1 plus 1 is 2, and then you do 1 plus 2 is 3, and then you do 3 plus 2 is 5, and so on. And you keep generating recursively, which means you generate it from previous problems. That's a very simple way to put it, which is also not always true, to create your overall solution. And this is not good for computer scientists. This takes a lot of effort. We don't want those things to be a lot of effort. So what's the way that we describe problems now? We describe them with our voices. And we want those people to be able to solve those problems with their minds. We want to be able to have this general problem that I want to do, and then we want the computer to be able to process that for itself. And that's where this idea of artificial intelligence came in. This is where Eliza came in and was showing some promise of natural language processing. And from there, people were like, okay, what if we were able to make the physical world directly interactable with our computer? And that's when we started seeing robotics start to take off, and the robots would interact with the world and could start to solve some of our problems. In which now you're getting into like that winter that I was talking about, where people promised a lot about AI. They saw a lot of this vision of you could have like actual humans roaming around and solving specific problems, or instead of factory workers, you could have robots that are automated to do the job, and you could have humanoid robots that could walk around and interact without having to change any of the interfaces that we currently have. Or you could just have, non-humanoid robots, and they would be able to solve specialized problems. But we had all these ideas of what artificial intelligence could bring, and which artificial intelligence at the time was as simple as saying, okay, somebody comes up to the register and you grab all the boxes and then you scan them and then you add them up. Or you see all of these numbers and you add them up. Like, these are forms of algorithms in which we're supposed to simulate the intelligence of a human. Like, that's what artificial intelligence is all about. It's a human fabricated representation of intelligence, but it doesn't think the same way that humans think. It still fundamentally was an algorithm that had some sort of decision making which you governed. And that's when things started to change. When I think it also was Turing. I forgot who it was, but they were like exploring whether a neural network could make decisions, and they proved that one layer of neurons couldn't do anything. So then people were like, what if we just made more? I don't know if you know this about your brains, but you have 86 billion neurons, generally speaking. I think that's an average. And they are organized in multiple layers. I think it's 6. And they interact in a very complex way. We can't fully understand it at the moment. But building from there, people were like, okay, let's just make multiple layers. And then we started seeing like glimpses of intelligence, of thinking. And you started to see, okay, we need more ways to interact with AI. We had Eliza, we had the robotics, we want to be able to upload images, you want to be able to speak to the AI directly, and then once the AI can understand what we are asking of it, what we are telling of it, when it can process pictures, when it can process images, and turn that all into text, now we're going to make it so it actually acts on it, and then creates the desired outputs that we want. And that's the very complex question that people are still dealing with today. How does my artificial intelligence turn the problems that I describe into problems that it can understand, and then how does it create solutions to those problems? And The answer for that is code, right? I mean, like, we have historically solved problems on computers with code. Why? Because the way that we developed code was that your computer is able to turn the physical problem that you're describing into one that can be just added, right? With your basic arithmetic operations, there's this thing in your computer, not in your computer, in the software called the ALU, and that's the arithmetic logical unit, if I remember. And that's where all the math and the logic gets processed. And being able to break things into these fundamental logical operations, which can be decoded with binary, like that's the whole thing with computers. It's turning your problems into problems that can be represented by just logic and math. And it's just so much more than it now today. But like fundamentally, it's always just been like, okay, how do I solve problem? How do I make it easier to convert my human problem into computer problem? And doing that with language and vision, the same way that humans process the world. Like that was the whole thing. That's all that it has been. And of course, it's so much more than that now, but that's where it started. And that's hopefully where it ends. And I feel like that's where we need to push, where I'm like, let's make it so it solves our problems. And that's like the ethical dilemma where you really wanted to push towards. And I just fundamentally, you see that and I'm like, it's not a computer problem. AI as a technology isn't particularly the issue. It's the people making it. You need to get mad at the people making it. To optimize for money, or which isn't inherently bad, but the whole addiction to social media thing, people get on that. Or you need to get mad at the people using it as well, and that's like a whole separate issue that I don't want to talk about. But yeah, that's my spiel on like how artificial intelligence came to be, or like why, at least from my understanding. And I'm gonna learn more about it. I have a class about it soon, but yeah. That's it for me. Maybe for now. Okay, bye.